Hi everyone, good morning and welcome to our webinar, Predicting Failures in the Process Industry, How to Calculate ROI. Chen Linchevsky, Precognize CEO, will walk you through how SumGuard calculates the ROI and will show some real use cases. The presentation will be about half an hour and at the end we'll have a Q&A session. You're more than welcome to write your question during the webinar in the panel and the dashboard that you can see to your right. And we will answer them as best as we can and as time allows. And with that, I hand it into Chen.
Thank you, Liat. Okay, so today we'll talk about how do we calculate ROI for these process or predicting analytics project that we're doing with SumGuard. But before we talk about that, let's talk a little bit about what's happening in the industry. And the thing that I want to share with you first, and I think we did it in the previous webinars as well, is the change that the industry has gone through, which is pretty typical to new technologies and the implementation of new technologies. So at the beginning, in the old days of 2016, 2017, people were so enthusiastic. They thought that this technology is going to change their life completely. And at that time, what people asked is, please implement your technology. Let's test your technology. The question of ROI was not even mentioned. At the end of that period, people started to cool down a little bit. And then when you came with the results of the project to the CEO, we had cases where the management actually asked, okay, but what did we try to achieve? What were our KPIs for the project? And we didn't have an answer because this was not thought of at the beginning. The enthusiasm was so high that we didn't really think, what are we trying to achieve? And this led to kind of a little bit of disappointment during 2018, which is, from my perspective, is completely not related to the technology, is not related to what machine learning AI can do. It just relates to the fact that the KPIs or the ROI of the project was not well defined. Now, gladly, we overcome that. And during 2019 and now in 2020, we see that organizations are starting to think, how can we implement predictive analytics? In our case, how can we implement SumGuard at scale? Okay, how can we do one plant and then continue to 3 plants, 5 plants, 10 plants, and so on? Now, the one thing that is extremely important when you do that is, of course, the return on investment. Because finally, when you do a real project, not the pilot, not the let's try and learn from it, you actually need to really prove that you gain something tangible or a monetary value to your project. And this is the background for our presentation today. What we want to focus is how do you calculate this return on investment? Now, before we do that, let's ask ourselves what are we trying to achieve? When we started at the old ages of 2016, the main thing that people thought about was the value of maintenance. How can we prolong the lifetime of the pump or the valve or whatever? Let's not change it every year at the overall. Let's try to drag or increase the lifetime. What we're seeing in the last years, and also due to the economy, is that the focus has shifted. And people today are looking more at the more production. Okay, how can we avoid failures? How can we ensure that our plant is running and producing as much as possible with the current equipment? And the increase of value when you produce, when you increase your production compared to the saving in the maintenance is really something that is not comparable, because the value of more production is much higher, especially in the market today, where most plants are heavily utilized. So the focus is more production, okay? But this brings us to 2 questions. The first one is, what prevents us from achieving more production? Okay, and this is something we need to think about. And the second is, how do we measure whether we are successful? So let's first address the first question: what's preventing us from achieving more production? Or I would look at it from the opposite side, or what are the opportunities to increase the production? And I'm looking at those opportunities from our, I would say, limited view of analytical applications. So when we look at analytical applications that can actually improve the production, we basically look at three types of applications. The first one are those applications that that really deal with the repeated known problems. Okay, yeah, I know I have my control loops that are not optimized. Let's optimize those control loops. Okay, a one-time effort which enables you to optimize your control loop, or any other things which are related to let's try to repeat the golden badge, or and so on and so forth. The problem is well defined, and once it's solved, it's solved. Okay, and it happened many times in the past. Okay, so for these types of problems, the second question of return on investment is pretty clear. Now, and I won't focus on that so much because this is not the area where SAMGUARD is operating. The second area is the major equipment breakdowns, and we see a lot of projects or customer demand around my most expensive compressor, or my most expensive turbine, or something that is really in the heart of operation, and if that fails, it will take 2 months to get the spare parts, and it's a disaster. The thing with these equipments is that in most cases they never fail. Okay, and most probably they would not fail also in the near future. So for these type of projects, to really prove ROI is almost impossible. Okay, so if you're aiming at this kind of project, make sure that your management is clear and sure that the value would not be something that you can measure. Okay, it's some kind of insurance that you hope that you would never need to activate. So these two areas are valid areas, but not our area. Where SAMGUARD is focused is on the daily job, on the daily things that are happening, on the things that are happening every day in the plant, those small failures that you can never, it never happened in the past, and it happens once, and now it happens again. And if you ask operation people in the plant, every day there is something. Okay, every day there is something. Now, in order to identify this something in advance, which is what analytical solutions do, you actually, it's not enough to just look at one compressor or just at the control loop. You actually need to look at the entire plant. So what we do at SAMGUARD is we are covering everything from the valves and the pumps and the boilers and the compressors and whatever the thing will be, we need to cover it. Because we're not dealing with those big things, and we're not dealing with the known thing where I know exactly what I'm looking for. We don't know what's going to hit us tomorrow. Okay, and it will be probably not a huge catastrophe. It will be small and small and small things. And just to give you an example and make it more lively, this is an example from a pulp and paper plant. Okay, and you can see the alert that we provided here. Now, these are, again, thousands of sensors that we monitor, hundreds of equipment types. And what you see here is the boiler motor. Now, you can see that there is some kind of deviation in the data. Okay. Now, it's not a boiler that, it's a catastrophe for the plant, but it's something that happened. It never happened in the past, but now it's happening. Okay. So all these small things that we give an early alert, which in this case we did a retrospective, so you can see that since it already happened, later on brought to a failure, these are the things that we're dealing with. Okay, and again, from another customer, just a list of things that were collected over a specific period, and you can see it may be part failure with the valve, it may be just a sensor that is suddenly faulty, it may be some kind of mechanical problem with another vessel, or it may be problems with the process. Suddenly we have low conductivity, or suddenly we have a blockage. We never had blockage there, but suddenly we do have a blockage, and we need to address it. And this is the daily things that are happening in the plant. And this is what we refer to when we're talking about the unforeseen events that we're trying to prevent. Now, in this webinar, we want to talk about the ROI. And the ROI, of course, have an importance when we talk about management, but it also have a very it's very important for the internal processes, because the thing is that those problems that I just mentioned have an accumulative effect on the plant. Okay, this is our claim, and we see it over and over. Those things, if you start solving them early, the accumulative effect of this continuous improvement is significant, and we'll talk a little bit later how do we prove that it's significant. But the thing is that for some people who are there in the plant for a lot of time, some of them will look at it as an opportunity. Yeah, now I know that this valve is going to fail. I didn't know it before, and yeah, now I can replace it earlier, or do some bypass, or change my processes and avoid this the harmful outcome of the problem. But some people will prefer to do things in the old way of how they did things before. Okay, and this is just normal. Now, the even more importantly, when we are looking at those unforeseen problems, those unforeseen events haven't happened in the past. Okay, the boiler motor, the deviation there haven't happened in the past. So there is no pattern that I can say, oh yeah, I saw this pattern, I understand what it is. Actually, you need to think, what does the alert really mean for you? What do you need to do? And you have to think, because it's earlier than what you used to face those kind of problems. So, and thinking is something that some users would really much appreciate, and some users will you know, try to avoid with the claim that there is no value in it. It's just small things, it's not important. So all this is really in order to say that the calculation of return on investment is super important. It's super important to management, and it's super important for the internal processes and internal people. Because once all of us understand what's the value, then the rest is just to implement. Now, so let's see, how do we do this? How do we measure the value of the solution, the value of those unforeseen events, the value of implementing SandGuard and seeing in advance that all those small things are happening before they actually hit us and create something. So the first thing that we thought about were the lagging KPIs. Now, lagging KPIs is basically indicators that are typically the output. Okay, it's for example, the plant utilization. Okay, the plant availability. All those things which are related to the bottom line. And those things have, you know, those lagging KPIs are actually what management would look at. So they have a really excellent potential to really show that we were successful. We implemented SandGuard, and now we produce a lot more. Okay, so on the surface, lagging KPIs seem like a great thing. Now, what we learned in reality is a little bit different. And we learned it also, and we heard from customers about other projects that they were doing. The reality is that when you apply a lagging KPI, you actually don't know what would happen if. What would happen if we didn't do this. So let's assume we have our plant and our plant availability is 98% or 95%, and the year after we implemented SandGuard, we are still at 95%. Are we successful or are we not successful? You don't know what would have happened if you weren't implementing SandGuard. Maybe your availability will go down to 90, and actually we gained 5%. Okay, so the alternative path just doesn't exist. Once you selected a path, you don't know what would have been the alternative. So it doesn't matter if you're producing the same availability or if you're producing more, or even you produce less. It may be that the situation of less would be much lesser unless you implemented the solution. So when we're implementing lagging KPIs, the first thing that we don't know is what is our baseline, because the baseline of last year is not necessarily the baseline of this year, and we actually don't know it. And to give you another example, which from a different angle for this difficulty, I would like to use this example, and here I would like to thank George from Titan America for providing this nice diagram. But it actually explains how you identify a failure. Okay, and it's basically, you know, a failure starts, something is happening with the actual equipment. What we basically saying is SandGuard, by looking at all the parameters, will be able to identify this failure here. Later on, probably, or maybe the vibration profile will change. Later on, the temperature. Later on, the oil maybe change, and then at some point you will be able to hear it and smell it and see it. And if you didn't do all these things, the equipment will eventually break. And this is kind of you know, clear explanation of the flow of a failure, which illustrates very well what usually happens. The point I want to make here is not so much about how a failure develops. The point I want to make here is about those points: can hear it, can smell it, can see it. And those three actions, which seem very simple, actually requires experience. Okay, each of these actions requires experience. I can go buy equipment and hear it and do not hear anything, and an experienced engineer who did walkarounds near this equipment for the last 10 years will immediately hear that something is of a problem. Now, if we go back to our point now, where we assume that the plant utilization like we have today will be the plant utilizations like we have next year, like the plant utilization the year after, we also assume that the people that can hear it, can smell it, can see it will be there for the next years. And to counter that, just in the US alone, 10,000 baby boomers are turning 65 every day, which means that they're going to retire. So these guys that can smell it, can hear it, and can see things that we humans cannot see, they're actually retiring. And to make it even worse, many of the workers in the new workforce are staying less than 5 years in the job, and now it's getting lesser and lesser and lesser. Okay, so our assumption that our plant will continue to perform the same way and provide the same utilization this year and next year, and so this can be our baseline, is probably in the long run completely inaccurate. Okay, so actually this assumption, if it's not correct, then those lagging KPIs of saying, okay, what would have happened if, we just don't have the baseline. We don't know if we achieve the same, it's good. If we achieve the less, it's actually not good. We just don't know. Now, in addition to that, in most process plants that I know of, there are many activities that are done on a daily, weekly, monthly, yearly basis in order to improve productivity, in order to improve availability. And nobody is just standing still and just implementing SAMGUARD and not doing anything else. So what's happening in reality is that if the utilization went down, okay, you were unsuccessful. If the utilization went up, okay, it's actually something else. We just changed the catalyst, and because of that, we're now our production is going up. So again, not because of anyone want to hurt anyone's chances. It's just the reality of things is that even if you're improving your utilization, it's very hard to pinpoint what was the reason. And this is exactly what we had in this project where we implemented the solution. You can see that before SAMGUARD, they had very high non-availability rate of very high unexpected shutdown of almost 40.5%. And you can see that with SAMGUARD at the beginning of after a very short time, we managed to get to about 10%. Okay, so we actually improved availability by 4.5%, which is, wow, huge, excellent. The thing is that I would admit myself, I don't know if this happens because of us. I don't know if this was not because of just pure luck or just something else I did in the plan. I cannot really completely relate it and correlate it with our activities. So being an analytical person, for me to just say, yeah, there is an improvement, but I cannot really correlate it with what we did, is not good enough. So at this point, we find ourselves with the situation where, okay, we had lagging KPIs. It's excellent. It's really correlate to the bonus plant of the plant manager, but we cannot really prove it. And it doesn't matter which way it goes. Still, it doesn't say anything about the success of the solution. So we have to change course. And the course we changed is into what we call direct indicator. Now, direct indicators are basically related to the output of the system. So if we go back to the alerts that we provided and we looked at in the previous slides, and we talk about these specific failures, the valves, the temperature sensor, the vessel, and so on. Now we asked the user, what would happen if? Okay, what are the consequences of not finding this problem in advance like we did here? And now it's actually for the user to try and think or simulate in his mind or her mind what would have happened if. Now, this of course has a range, because I can give you an example from a project that we started, and we talked with the process engineer about a problem they had in the past before we actually started the project. And they had the problem with the controls, with the steam control valve. As a result of that, the reaction was not good. As a result of that, they lost batches. Now, in reality, they lost 6 batches before they found the problem and fixed it. And this is pretty typical. Until you understand what's going on, until you understand that you have a problem, time goes by, 6 batches were lost. Okay, and this what really happened in reality. Now, let's assume we are now with SAMGUARD, okay, and we have this kind of problem, and we identify this in advance. Now I'm kind of asking the process engineer, what do you think would have happened unless we found this problem early? Now, if I ask him for a specific number, it would probably be wrong, okay? And this is why we decided, okay, let's not ask for a specific number, let's ask for a range. What would be in the best case scenario? The best case scenario, let's assume, yeah, you didn't find it immediately, but you were really clever and you caught the reason very fast. And maybe then in this case, the process engineer will say, okay, we lost 2 batches of production. And what would happen in the worst case scenario? Okay, worst case scenario, it took you more time and you were not really alerted and didn't pay attention. And he probably would say, okay, in this case, we would lose 8 batches. Okay, so now we know now in reality that they lost 6 batches. But once you give a range, it's something in the middle. Okay, it will be maybe in the exact middle, maybe more to one of the sides, but it gives you a pretty reliable indication of what are the consequences of finding or of not finding this problem in advance. Okay, so what we ask the user is to basically add 2 columns here and put it in real money. What is the minimum estimated cost if it was not identified? Okay, what are the consequences in the best case scenario? And what are the consequences in the worst case scenario? Okay, now the truth is something in the middle, but this is a very good indication for the value. Now, these alerts, by the way, are from 2 months in the plan. Now, then we ask for another thing, which is only for advanced users to think about. This is the exposure, because let's assume that we have 10 valves like this in our plant, and we know that these valves can fail. So actually, the risk, the exposure that we have is 10 times greater than something in the middle of the best and worst case scenario. Okay, and this is something that it's more for the CFO, it's more for financial thinking, and later on insurance thinking of where this value can be gained from. But let's stick with the best case scenario and the worst case scenario. So for these 2 months of operation, for these 2 months of alerts, we basically got to a value between $140 to $4 million in savings. Okay, and that's without getting into Samgard pricing, it's much more than we price for those 2 months. A huge return on investment. Okay, so here we're actually able to provide clear value, which is directly connected to the events that were triggered by the application. Now, once we understood that the method, then in the newest version that we release now, we actually incorporate that into the software, and we allowed or placed a scholar here, which allows the user to select this range. Okay, now we did it like this and not in exact number, but on purpose, because we don't know the exact number. Okay, and none of our users would actually guesstimate 6 batches. Okay, they would guess something which is in the range. So what we care about is not whether it's $1,000 or 1,001. What we care about is it's a range of 1,000 to 10,000, or the range of I don't know, 20,000 to 100,000, and so on. Okay, and for each alert from the types which are meaningful, basically the user is adding the value, the range of value, best case scenario, worst case scenario, and all these inputs are actually aggregated. Now, keep in mind that when you do this range, we actually incorporate 2 components. Okay, one is the downtime cost, which is clear. Okay, if this would break completely without an alert, we'll have 1 day of stoppage. This is how much it's worth for us. The other thing, which is, again, as I said from the beginning, maybe less money, is reduced maintenance cost. Because if we look at our pump, for example, and let's assume that over the time we gave the alert here, while the control room also gave alert, but a little bit later, it may be that here it's only to add oil and everything is great, the vibration will go down, nothing will happen. And here it will be to replace all the bearings, so it's not just the cost of the bearings, it's also the cost of the work, the maintenance work is longer, and so on and so forth. Okay, so this estimation is actually incorporating both factors, the downtime cost, which is of course greater, but also the reduced maintenance cost. And once you do that, we can actually aggregate that into a dashboard, which is available for all of us, because it's not just for management to know, okay, how much money did we save? It's also for our internal purposes. Those people in the control room or those process engineers, they do work, they look at the alerts, they solve things. They want to see that it's actually brought value to the organization. So all these values are actually aggregated into the dashboard, where people can see online how many cases there were there, how much money we saved in the best case scenario, and how much money we saved in the worst case scenario, and have a clear indication for where we are. Now, so this is the part of capturing the ROI, but there is another part to it, and this is a part of the effort, okay? Because let's assume this great thing of discovering problems in advance by the software is great, but let's assume we could hire hundreds of employees. Each of them would look at all the data all the time. Each of them will walk around the equipment and listen and smell and look at it, and it will be a huge investment. Maybe we'll get to the same results, okay? So we always need to estimate the effort of hiring another person, or hiring 1 or 2 or 3 or 5 person, compared to taking a software. Now, of course, the software has a huge advantage by it doesn't go to sleep, it doesn't go to lunch, doesn't take vacations. It's there 24/7 working, looking at all these thousands of sensors all the time. But still, you have to look at the effort that you invest into the software. Now, and the reason effort, because you actually, once a software triggered an alert, somebody would need to look at it, and somebody would need to take some kind of first thinking, what should we do, and then take the action. So to complete the ROI, we have to look at the effort. And this is something we put ourselves as a target from day one. From day one, we said, okay, we're not going to be like the control system, which triggers hundreds of alerts. Most of them are ignored. People hate it. And it just, it just have to be there. I mean, we have to have these kind of alerts, but it's not very useful for additional production. And this actually works for us. So if we look here at an example, this is the closed events report from for a year, from 26th of January last year to 26th of January this year, very up-to-date thing. And you can see there are different reasons here for closing an event. And each customer, by the way, can set their own reasons and their own classification. Some set leakage, sensor problem, equipment failure, planned maintenance, so on. Some set like you're seeing here. Keep in mind, and just to align the expectations, is that not all alerts are valuable. Not all alerts will increase your productivity. For example, planned maintenance. If you do planned maintenance, of course, the data will become crazy, and will probably trigger an alert. Now, in a perfect world, of course, the software would know that there is planned maintenance and would not trigger an alert. But in reality, in most plants, this is not all the data is connected. So yes, you will get an alert about planned maintenance. But the question is how many? And when you look at this case, we're talking about a year, 365 days in that year, and you actually get 212 alerts. So it's actually less than 1 alert a day. Okay, and when we're starting a new project, we're committing to, let's say, anything between 1, 2, 3, and up to maximum 5 alerts a day. Okay, again, it's not that the software would stop at 5. If you're suddenly the plant is going crazy, you may get more, but on average, you get very few alerts a day. Okay, so if we think about the effort now in the control room, or even the process engineer, to look at 1 alert per day or 2 alerts a day, we understand that the effort here compared to the 140 to the 4 million of saving is completely negligible. The effort is really small, the value is really big. Okay, so with that, I would like to conclude and summarize. And basically, you know, we're sure and we know and we see from experience that more production can be achieved by preventing those unforeseen events. Those continuous improvements are very important, are taking the plant to really the next level of availability. But the measurement of this value must be done only by the direct indicators and not by the lagging ones, because only the direct indicators will bring you the really measured value, which is connected to the alerts that we're producing. And of course, the whole thing is valuable as long as the value exceeds the effort. And keep in mind when you're evaluating any analytical solution. And I can say, you know, just as a closing remark, I see many customers that are saying, can you catch this kind of failure? Can you catch this kind of failure? The thing with analytical solution is not so much to catch the problems. The thing with analytical solutions is how to avoid the noise, how to avoid the false positive, how to make sure that the effort that you're making in order to achieve this value is something that you can bear, that the operation people can bear. And I think with SamGuard, as you've seen, we're doing a pretty nice job in balancing this and setting huge multipliers of the effort compared to the value. So with that, I will shift to Liat and we'll open for some questions.
Thank you, Chen. So there are a couple of questions here. One talks about the effort that you mentioned a lot, and how do users really do they cooperate with producing these reports, which is part of the effort?
Okay, so I would say I think it's a very good question. The effort is a tricky thing, because if you look time-wise, it's nothing. Okay, yeah, a few minutes of evaluating the alert, it's not a big deal. And if you find something, of course, you will need to do something about it. But this is something that you know, you would do anyway, and it actually saves you time. But it's different type of thinking than the thinking you used to have. Okay, in the past, before you had this analytical solution, you would actually ignore those small things. You would not even handle them. You would handle them once they hit you and something failed. So now you need to think in advance. Okay, these small things, it's actually very small. I need to address it. Okay, I need to address it, although it's very small. And this is actually a shift of paradigm from chasing fires, okay, the things that hit me all the time, into let's take things in advance. And the nature of people is to chase the current fires. And I think here it's not so much about the effort, but it's about the responsibility of management. Management must make sure that there is a shift of paradigm from chasing fires, chasing the immediate crashes that you have, into looking at things in advance and looking at trying to solve things in advance. Now, the technology is there. I mean, we give alerts about things that are going to happen, and we'll give it very early, from days to weeks, in a rare case, sometimes hours. But people need to, or management need to make sure that people are aware that we're changing paradigm. We're handling those small things when they're small, instead of handling the big crises when they actually hit us.
Thank you. You mentioned the technology, and here's a question about the technology. Does your technology provide more ROI than other solutions? And if so, you could tell a little bit how.
Okay, we didn't touch in this webinar the technology at all, but I think the question that you need to ask yourself is related to a combination of the ROI and the effort. Okay, we have seen from other technologies that you're getting hundreds of alerts a day. And if you're getting hundreds of alerts a day, people would get into the situation of what we call alert fatigue. Okay, so the thing that you need to make sure is that the number of alerts that you're getting a day is somehow approximately correlates to the number of problems you have a day. Maybe a little bit more because there is always false positives, but or false negatives, but it's somehow related. If you're getting hundreds of alerts a day, okay, and these hundreds of alerts are actually, and in the plant you have 10 problems that you address every day, then it means that most of the alerts that you're getting are just noise in the data. Yes, there are anomalies in the data, there are some deviations in the data, but they're not representing a real operational problem. And I think the big thing that we have done with SandGuard is that we have managed to differentiate between those anomalies in the data, which exist all the time. Okay, the plants are never really stable. Everything is moving. Anomalies exist all the time. So we differentiate between the anomalies in the data and problems in the plant, and we manage to aggregate those alerts, those anomalies, into the very few operational problems. Now, the solution is based from two components. The first one is finding those anomalies. Okay, and in that we're using unsupervised machine learning, which actually looks at all those thousands of sensors, all of them, on a minute interval, and find when some things are abnormal. And believe me, our solution is top of the line, automatically decide which machine learning algorithm to use for every tag. Really great, but still there are many anomalies. Okay, all of them are valid from a data perspective. Most of them are not relevant from operational perspective. Now, what we do in the second step is that we actually create something that now the buzzword is digital twin, but we call it a graph. We create during the implementation a causality graph, which is not something that we use the data for, but we use the PNIDs, flow diagrams, and the knowledge of the people in the plant in order to create this causality diagram. It takes usually we implement in a significant plan something like in 2 weeks. And then we use this causality graph in real time in order to imitate what the process engineer, if he could look at all these anomalies and decide which of them are meaningful, it's actually we're trying to imitate this process with the causality graph and aggregate all those anomalies into very few alerts. And this is why you've seen in the graph before 212 alerts for a year versus thousands and thousands of anomalies that were created at that same time. Okay, and this is really the power of SandGuard, the ability to distinct between anomalies that are created by the machine learning and aggregate those anomalies into meaningful alerts.
Okay, a question that's asked more specifically about the machine learning. Is it used in the software itself or in another program like Python?
The SandGuard is a holistic solution. Okay, it incorporates the machine learning, it incorporates the graph analysis, it incorporates all of it. So it's you install and it runs. Of course, we didn't invent machine learning. Okay, and we try not to invent the wheel if somebody else did. But the interesting thing here is that the software itself knows how to determine which algorithm which machine learning algorithm is correct in each situation. And in some cases, it will be neural networks. In other cases, it will be a nearest neighbor. In other cases, it will be other algorithms. So actually, automatically, the software decides for each equipment, for each environment, for each group of tags, what would be the right statistical machine learning method to encapsulate the normal behavior of those tags. And once it deviates from the normal, then it creates anomaly, and this anomaly is then being projected on the causality graph and being evaluated of whether this anomaly, together with the other hundreds of anomalies which are created at the same time, are really reflecting a problem or not. So yes, the machine learning is part of the solution, and it's an excellent machine learning. Super fast, super efficient, but still creating anomalies only where we aggregate them later on in the second step.
Can it be used for all kinds of equipment, and is there a standard?
Okay, so the question is, can it be used for all kinds of equipments? The answer is yes, assuming that you measure. Okay, so I would say we cover static and rotating equipment. We see problems with valves, and we see problems with pumps, and we see problems with catalyst and with heat exchanger. And you sometimes can identify blockage in the heat exchanger, not by the behavior of the heat exchanger, but because of the behavior of the valve, which is before the heat exchanger was suddenly changing its behavior because of the blockage. So we can see everything, or potentially see everything, but it really the real answer is subject to what do you measure. So if I take the heat exchanger example, like that I used now, some heat exchanger will have temperature before and after, and flow before and after, and then control valve will have all the parameters, the set point, the OP, and so on. And others will decide, okay, we only have the temperature after, not before. Okay, so the more measurements that you have, the better the chances that we'll be able to identify problems. So in terms of the types of equipments, we can cover any type of equipment. The question is what is measured. Another thing that I think it's obvious but must be said is that there are problems which develop immediately. Okay, we had crack in the pipe, high pressure pipe. Once a crack started, boom, it completely cracked. So in those cases, there is nothing we can do. First, there is no data about cracks. Okay, but the second, it happens so fast that it just it doesn't matter. Our belief, just like I showed in the diagram that George made, our belief is that problems usually start from the physical change, and then you usually have time where those problems are evolved. And if you aggregate all the data around this equipment, in most cases you will see something is changing during this time, and we'll be able to trigger an alert which will enable the users to prevent the actual failure.
Actually, one last question to conclude. It's a very good one to conclude. At the end of the day, would you say that those direct problems affect availability?
Okay, this is an excellent question, and I talked to one of the managers of one of our customers, and he basically said, listen, if I took the ROI from all the projects that I'm doing and aggregated all of them together, probably I would be in 150, 170% availability. So the reality of things is that it all sums up to improvement. Okay, and if you stop doing those continuous improvement projects, doesn't matter if with SunGard or with something else, it doesn't matter if it's analytical or something else, things will deteriorate. Okay, so is the value that you're seeing here per event is exactly the value that you would lose? I don't know. And as we said earlier, we don't know whether this availability that we had last year, if we wouldn't do anything, it would maintain the same. Probably if we wouldn't do anything, it will go down. And the fact that we did what we did, for example, implemented SandGuard, has actually helped us to keep it in the same level or maybe higher. So because we don't know what is the baseline, we don't know what would have happened if in this year, then we're in a situation that I don't know, I don't know what to answer and be completely analytical proven. But the assumptions that I'm making is to continuous improvement. If you don't do these kind of projects, the availability will go down. And second, it's a good measurement. It's a good measurement to understand what is the influence on the plant, although it's not necessarily the exact number that you gained into availability. And third, keep in mind that nobody is promising you, if you don't do those projects, nobody is promising you that the availability that you had last year will continue this year and will continue for the years after. Probably it wouldn't.
Thank you, Chen. And I think we'll conclude this session. Thank you very much. Thank you guys for joining us today. And please feel free to ask any more questions that you have. We'll send you materials, whatever you require. Thank you.
Thank you very much.